Okay, so in this next video, what we're going to do is we're going to take a look at getting the equation of tangent and normal lines. And that's going to use the derivative. And if you're looking at the screen and you say, okay, well, we've already done definition of derivative, you are correct. Okay, I'm just going to take a look back at something we looked at maybe a week ago or so. And you see that one of the ways that you could be asked for a derivative is to be asked for the slope of the tangent line, right? If we take a look at the diagram in the lower right corner, you can see that the instantaneous rate of change is the slope of the line that touches the curve at one particular point. So whenever you're asked for slope of tangent line or instantaneous rate of change or y prime, it's all interchangeable. So in this case, okay, when we look at tangent and normal lines, we have to get the derivative. And what I'll say is that in general, in calculus, at any point in time, if you're not sure what you have to do any sort of problem, start by getting the derivative. Okay, derivative is pretty much in every question that we do. So we're going to move forward here. We're just going to go through things that you've already seen here, if you're doing this in order. And we're going to move right along to normal and tangent lines. So before we do that, okay, just going to give you guys a very quick review here of something that you probably did in Numbers 10, and that is get equations of lines given a slope and a point. So you're used to getting equations of lines where you have a slope and y-intercept. You can put it in slope point form instead, and the formula would be y minus y1 is equal to m, the slope, outside of x minus x1. So here we have all the information that we need. We have a slope, which is negative 2 over 3. And we have a point, 4, negative 5. That's our x1, y1. So we can put in x minus x1, which is 4. And y minus 5, which is really a plus 5. And we now have our equation that has that slope and passes through that point. Okay. And then another thing to remind ourselves is that normal lines, not even sure if you've heard that term before, but a normal line is perpendicular to a tangent line. So tangent lines and normal lines meet at 90-degree angles. And just a reminder how the slopes of perpendicular lines go. If you have a slope of a line that is negative 2 over 3, then the slope that is parallel to that would be equivalent. So it would be negative 2 over 3. The slope of a line that is perpendicular, meaning that it meets it at 90 degrees, what you do is you take the slope and take the reciprocal of the slope, which is now 3 over 2, and you change the sign in front, so instead of a negative, it will be a positive. So that's going to be useful for some of the videos that we're going to see now on normal and tangent lines. Let's start off with a tangent line. Now this one here, you're not actually asked for the equation of a tangent line. You're just asked for the slope of a tangent line. So in this case right here, okay, what we can do is, of course, whenever you see the word tangent line, slope of a tangent line, we know we have to get the derivative. So now that we know the shortcut, we're definitely not using the limit formula. So I can make that into negative 6x squared plus 4. That is an equation that gets you the slope of the tangent line, but it's not the slope itself. Okay, that's the equation of a parabola. But what we can do is we can plug in the x value of 1 to get the actual numerical value of the slope, and you're going to wind up with negative 2. So if the question, which it does in this case, just asks for the slope, then we have completed our question. Why don't we add to this, and let's find the equation of the tangent line. Just in case you're asked, because you will be asked for equations of tangent lines coming up. So why don't we do that next? And of course, okay, what we need to do is equations of lines in general would be this formula right here. And we already have our slope of negative 2. We need our x1 and y1. So what we have here is sometimes you're given both the x and y values. In this case right here, you're just given the x value of 1. So we need to get the y value of at that point as well. And we're not going to use a derivative to do that. Okay, anytime you need to get a y coordinate of a point, you just plug into the original equation. So in this case here, I'm going to go back and I'm going to put in 1 for x and I'm going to calculate the y coordinate, which in this case, okay, will give us a positive 2. So now we know we have 1 comma 2 as our x1, y1. And now I can go back to my equation and I can say, okay, now I have 1 and 2 in for x1 and y1, and this is the equation of my tangent line. So just make sure you read the question carefully. Sometimes you're just asked for slope, which is easier, so you would leave it at -2. Sometimes you're asked for the entire equation, and you have to go a couple of steps further. And if you wish to, okay, you can check Desmos to see if you have the answer correct. So take a look at this. I graphed both the original function in red and the slope of the tangent line, or sorry, the equation of the tangent line in blue, and you can see that this right here is definitely a tangent line at that point 1, 2. Okay, it definitely just intersects or touches that curve at one particular point only.